Hi everyone, I am Balal Afghani and I'll be introducing you our research, which is entitled Extracting Palladium Using a Special Selective Compound. The writers of the research are me, Ahmed Azzuddin, and Laith Sheikh, and the scientific advisor of the research is Dr. Muthanna Al-Qubayli. And we'll start with the introduction. We all know that researchers and scientists have a long history of working hard to find new ways to extract precious metals. So we, as researchers, we wanted to play our role in this process. And by doing some research, we came up with the idea of finding a palladium selective compound which we called ABL. And since that you have no idea what ABL exactly is, we need to know it. First, ABL is an organic compound. Its formula is C5H8N4O4, and its name within the AOPAC system is displayed on the screen. Second, we can see the stereostructure in the figures on the screen, and as we see, it's like a half-hollow sphere. And here we come to the main question in our research, which is why this compound is a palladium selective. As we can see, there's a semicircle and its radius can be determined by calculating the distance between two opposing oxygen atoms. And for that, we did some methods over here to make that radius almost identical to the radius of palladium with oxidation state of +2. Let's go now to 3 steps to extract palladium. The first step is dissolving palladium. The second step is transferring palladium from the aqueous solvent to the organic solvent. The third step is palladium deposition. And we'll go into details now. The first step, palladium dissolving. As the figure shows, palladium can be dissolved by reacting with aqua regia, then by doing some leaching, we get PdCl4 with oxidation state of -2. The second step, transferring palladium from the aqueous solvent to the organic solvent. It's going to happen throughout the following reaction. As we see here, the 4 oxygen atoms will bind 4 coordination bonds with the palladium with oxidation state of +2, making a chelate compound, and we do expect that the association constant value would be high because ABL is a promising chelating agent to bind with palladium because of its stereostructure. Now let's head on to the third and the last step, palladium deposition. Palladium can be deposited using an electrolysis cell, then it's supposed to be collected, washed and dried, and it's going to happen throughout the following reaction. Unfortunately, we couldn't find a synthesis method, so we put forward a promising method. It consists of 3 main steps. In the first one, we started from 2 equivalents of compound number 1 and we have got compound number 2 with 2 new ether groups using an ether formation reaction. In the second one, we did an amine deprotection reaction to get compound number 3. In the third one, we did an imine formation reaction, then we added HCl, and after that, using a condensation reaction, we have finally got ABL. And we'll end it up with the conclusion and the results. In this research, we extracted palladium using ABL, which is an organic palladium selective compound that we have found and we have predicted its synthesis. We believe that our method to extract palladium is one of the best out there, because it is original and it does not depend on the popular costly methods, such as the precipitation and diffusion method. Moreover, ABL is a reusable compound and also it is a friend of the environment. Let's move to the results. Palladium can be deposited more easily in an organic solvent than in an aqueous solvent. ABL compound transfers palladium from the aqueous solvent to the organic solvent with high selectivity. Precipitation and diffusion method is costly and involves a lot of difficulties, which can be avoided by using the suggested method. And here are the used references. And thanks for listening.